Okay, students, so this is on page 98 of the notes. It is hypothesis testing, but now we will be testing the population mean mu when the population standard deviation sigma is unknown. So x will be a random variable that we define. We're going to obtain a simple random sample of size n of x values from which you compute the sample mean and sample standard deviation. Again, sigma will not be given to you. So we will be doing a hypothesis test following these basic steps. A calculator note: if you choose to use your calculator, when you do not know sigma, you must use a t-test instead of a z-test. That is an important distinction. So let's flip to page 99 of the notes, and I've written above on example 8.9 that this is a test for mu when sigma is unknown, and we will be doing the critical value method. You may use the p-value method, or you may use your calculator to do this example. I read through the example, and this is about rocket engines, and then I collected the information and I put it in a little box, okay? So take a moment to read through the paragraph on your own, and then join back in with me when you're ready to start the work on the problem. Okay, so now you should know where I got the information, and if you read the paragraph, you'll know that they were claiming that their rockets consumed 5,500 pounds of fuel, okay, within the first 15 seconds. And the government inspector is suspicious, isn't he? So he took a sample, and we were asked, is the manufacturer's claim justified? When they ask if it's justified, they just want to know if it's any different than what they're claiming. So we're going to use a not equal to statement. Okay? Now this is a two-tailed test. It's two-tailed, and n is 6. Now a critical value for a t-test, when you don't know sigma, is alpha n minus 1, and then how many tails you have. N minus 1 is your degrees of freedom. We have n is 6, so 6 minus 1 is 5. We'll be looking for 5 degrees of freedom. So I'm going to go to my t-table, if you remember this from when we were doing confidence intervals. You'll notice on the top you have a one-tail area and a two-tail area. Again, this is a two-tailed test because we have that not equal to statement in the alternative hypothesis. We're going to go down 5 degrees of freedom, and we're going to scroll over to our desired level of significance, which was 5%, which is right here. So our critical value is 2.571, and because it's a two-tailed test, it's important for you to manually put in plus or minus, because it's a two-tailed test, and the t-table does not tell you that directly. It tells it to you on the side here in the two-tail area picture. Okay? So when we do our rejection regions, we are going to color in both the right tail and the left tail and label them both as our rejection regions. We just want to see if the fuel consumption is different than what they were claiming. So that's a two-tailed test. Okay? The next step, of course, is to move to your test statistic. Take your sample mean, subtract the mean they were claiming, divide by the sample standard deviation, and divide that by the square root of n. You should get a test statistic of 1.86. If you're not, make sure that you're doing your numerator and your denominator separately, or entering them into parentheses like I have now. Once you get your test statistic, you look to see where it falls in your rejection region picture. Does it fall in a rejection region, or does it fall in the unshaded region? It falls in the unshaded region, so we are going to fail to reject H naught. Okay? Since we are failing to reject H0, we will say, based on the evidence, there is not a significant. You look at your symbol in your alternative hypothesis. This indicates significant difference. So we're going to write the word difference. Either way, right? We don't care if it was too big or too small. We want to know either way. So based on the evidence, there's not a significant difference of average. This was talking about fuel consumption. Was the variable of interest of they were claiming 5,500 pounds at an alpha of 0.05. Okay? So that is the critical value method of hypothesis testing when sigma is unknown. Stick around and I will show you how to do the same example, but this time using the p-value method with your calculator.